Why don't we knock this page out, because we can knock it out in about 2 minutes.
Which one?
The one we're looking at? You only made one mistake on this page.
Oh, which page is it? It doesn't say like what,
It's quiz 9.1 to 9.3, page 2. Can you see it on my screen?
Yeah, I don't see the top page, the first one.
Well, I don't know. I don't have them in order. I just saw this one. I figured it's only got one thing on it. We can handle this in 2 minutes.
Okay, let me find it.
You don't even need to do that, Sam. Just here, let me write the function down and let's talk about the principle.
Well, what about the front page?
We'll get to that.
Huh?
I'm not. I got your 3 pages of attachments.
My mom sent it, so I'm not.
Okay. Okay.
Page a lot of corrections to be made.
What's that?
Page 1 of this has a lot of corrections to be made.
I know. I saw that. I want to start here because we can knock this out. We don't have to deal with this page anymore, and I can knock it out in 2 minutes.
Okay.
Okay. What is the horizontal asymptote of that function?
I think, how do you find it?
Hold on. When you say let you find it, what are you doing? Are you looking up formulas for these?
No, I just sort of forget because it's been a while, like a week, because I'm on break.
Okay, that's fine, but you do want to memorize this stuff. In other words, I can't imagine that when you take a test, they let you bring in, they don't let you have like a cheat sheet, do they?
Nah, not really.
Okay, so let's talk about how you find the horizontal asymptote. When you have the power in the numerator is the same as the power in the denominator.
Yeah.
And that's what we have. We have an x squared in the numerator. We have an x squared in the denominator. This is a hyperbolic function that's going to have vertical asymptotes and horizontal asymptotes. Well, you got the vertical asymptotes correct, plus or minus 2, but you got the horizontal asymptote incorrect. The horizontal asymptote is the ratio of the coefficients, which is 1 over 1.
Oh.
So the horizontal asymptote is 1.
Okay.
Okay, that's all we need to say about this page. Let's get rid of it. Now we can go to the other pages she sent.
Okay.
We've got Sam's math corrections. This is probably the one you were wanting to start with. Is this correct?
Sure, yeah, that works.
Okay. Well, statistics is the big thing anymore. They've added so much statistics to the Common Core program. It's shocking to me. Okay, you didn't miss anything on 1, is that correct? 1, 2, 3, okay, so 4. Find the 30th percentile and the 65th percentile. I presume they mean of the frequency distribution above?
Yeah. Probably.
Okay. Well, I'm not sure. Let me look at this. First of all, is this all the same problem? Let's see. The following scores. Yeah, okay. So he gave a test and we're just looking at it. Find the 30th percentile and the 65th percentile. Well, let's think about that for a moment as to what that must mean. First of all, you need to put all of these, what exactly did you do up here? The first step is usually to put all of these in order.
Yeah, that's what I did.
Oh, I see. 78's the first one. I don't see them in order at all. Where are they in order?
On the bottom, underneath the...
Well, that goes 83, 90, 96, 98, 64. That's not in order.
Oh, I don't know. I did this a long time ago.
Okay. So you did this maybe on a separate sheet of paper.
Yeah.
Okay.
Can we just skip this if you don't know what to do exactly?
Yeah.
Okay.
I know exactly what to do, but it's going to take a while, and we got a lot of material to cover. Here's what I would do. I would line them up all in order, okay?
Yeah.
Now, the median is the 50th percentile. So if you want to know what the 30th percentile is, go to the lowest 30% of scores. And the highest score in that group is the 30th percentile. You know what I'm saying? Can you hear me? I just heard a sound like maybe like we lost audio. Oh, I forgot. We're doing our audio on the phone. Yeah, let me just give you an example here of what I mean. Let's say we had a score and the maximum score was 10. Okay? And we had somebody that made a 1, somebody that made a 2, a 3, a 4, a 5, somebody else made a 7, there were a couple of 8s, and there was a 9, and somebody had a perfect score. Okay? So, if we wanted to know the 30th percentile, it's the lowest 3/10 of the scores. The 1, the 2, and the 3. Although the 3 is exactly at the 30th percentile. And I don't get that because it's a 3. I get it because it is the third position out of 10.
Yeah.
Okay? 50th percentile is that. Well, guess what? The 60th percentile is that, 7. Because if you took the lowest 60 percentiles of these 10 scores, that 7 would be the highest of those 6 scores.
Yeah.
Okay, so that's the way that works. So, but the first thing I would have to do in order to answer the question is to see it all written out in order. Because it's really hard to analyze large pieces of data if you don't have them in order, especially when they're asking these kind of questions.
Yeah, let's just go on to the next thing because this is like...
Well, okay, what's the next thing?
Any of the other worksheets.
No probability? Let's say I don't see any deductions here.
There is.
Number C? All right. Let's look at number 8. In other words, you want to go to just where you lost points.
Yeah.
Okay. All right, let's look at number 7. Seven of the songs are your favorite right now. What is the probability that the first 3 songs played are your favorites? The only thing you did wrong there was you need to multiply, not add. In other words, what is the probability that the first song played is one of your favorites? That's a correct statement. That has to occur. And then I'm going to multiply it by the probability that the second song played, which can't be, now your list of favorites is down to 6 songs, and there's only 11 songs to choose from. And the third song, there's only 5 favorites left out of 10 songs. So when you multiply those 3 fractions together, you get the odds, and the odds aren't going to be very good. In other words, it's approximately 1 out of 8. You can put this in your calculator if you want, but the odds are only going to be 1 out of 8, which is like 12%. Okay? And you should have some idea of a ballpark number when you're doing these problems. In other words, it can't be very likely that the first 3 songs played are all going to be your favorite songs. It might seem like 0.54 is a reasonable number, but not really. In other words, if they picked 1 song to play, 0.542 would be probably as what 7/12 is. But if you had to have 2 successes in a row, well then that's going to be about 7/12 times 6/11, and so forth. But always remember with probability that if all events have to occur, then you are multiplying, not adding.
Right. Here, one sec. I just have to run upstairs and grab my calculator real quick.
Okay.
I'll be right back.
All right. Okay. Number 8A. You got the probability correct, but then when you simplified the fraction, you got it incorrect. That's why you lost a point there. So let's talk about that. How'd you make that mistake? Let's figure it out. It looks like you converted it to 4/13. Is that your original answer?
Yeah.
Okay. Notice that the only way to convert this is divide the top and the bottom by the same number. Well, I can divide the top by 4 and I can divide the bottom by 4. That gives me 13 in the bottom, but 8 divided by 4 gives me 2. Now I know it's simplified. Well, let's look at that for a minute and say, well, how did I know I could divide this by 4? Okay, let's say I didn't. I do know I'm looking at 2 even numbers, so I can divide that by 2 and that by 2. And that gives me 4/26. How do I know that's not simplified? Because it's still an even number over an even number. So I can definitely cut the top in half and the bottom in half. Now I got a prime number in my numerator and my denominator. That's got to be simplified totally.
So that's the answer?
2/13. That's the same fraction as 8/52. You got the hard part correct. 8/52. The part you missed was simplifying the fraction. All right, part C. Find the probability of choosing a diamond or an odd-numbered card. Well, there's 13 diamonds, and this is an OR question. OR questions, you do add the fractions. Okay, it's only AND questions that require you to multiply. So for an OR question, I'm going to take the odds of choosing a diamond, which aren't 13, they're 1 out of 4. In other words, they're 13 over 52. In fact, let's write it like that because we'll leave the simplification to later. You don't need to simplify in the course of a problem. You need to simplify your final answers, and that's it. I don't care if you don't simplify during working out a problem. Okay, the fact that that word says or means that. Now, or an odd card. An odd numbered card. Wow. Oh, don't count aces, and I presume don't count faces. In other words, an odd number card from 1 to 9?
I don't really know cards very well, so I sort of hate when I do these.
Yeah. Well, a deck has 52 cards, and there's 4 suits. So there's 13 cards from each suit. And they go ace through 10, and then jack, queen, king. And the jack, queen, king are called face cards. Aces, it says don't count aces. At all? Gosh, this problem is worded fairly poorly because it doesn't say whether you're not supposed to count the aces including the diamonds. In other words, let's say I'm not to count any of the aces. Okay? So that means we have 48 cards and we have 12 diamonds. So there's the odds of, and that's still the same odds of picking a diamond, even if we remove all 4 aces. Okay? So that's 1/4, but we'll leave it at 12 48ths. Or an odd numbered card.
That's like 1/2.
Well, depends. It's not necessarily 1/2. Jacks, queens, and kings aren't really, that's not really an 11, 12, and a 13. So I think she means the odd numbered cards from 2 to 9. And that would be 1/2. In other words, if you're talking about only, or 2 to 10, 2, 3, 4, 5, 6, 7, 8, 9, numbered cards, she has to include 10. Okay, well, of those 9 cards, 1, 2, 3, 4 of them are odd only. So I would say, given her criterion of not counting aces, notice that if we counted the aces, we would have exactly 50% of the cards would be odd, because an ace would be odd.
Yeah.
But she doesn't really specify whether we're to exclude the face cards, the cards that have paint, jack, queen, king, because those don't have numbers. We don't know whether they're odd or even. So according to her specifications, there would be a 4/9 chance of choosing an odd card. And now you got 1/4 plus 4/9. And you can add those 2 fractions to come up with a number.
Okay.
All right, let's go to dice. Dice are a little easier because it's not 52 of them. There's only 6 faces on a die. So if you have 2 die, you have 6 times 6 possible outcomes. So you have 36 possible outcomes. Find the probability of rolling a sum greater than or equal to 10. Well, greater than or equal to 10. So let's see. The lowest would be a 4 and a 6, right? In other words, you couldn't do a 3 and a 7 because there is no 7 on a die. And the other possibility is 5 and 5. The other possibility is 5 and 6. And the final possibility is 6 and 6. Those are the only combination. Oh, no. There's also 6 on the first die and 4 on the second die. And there's also 6 on the first die and 5 on the second die. Now, each of those is unique. Okay? So if I want to know the odds of this happening, rolling a 4 on the first die and a 6 on the second die, that's got to be 1/36. Because the odds of rolling a 4 on the first die are 1 in 6. The odds of rolling exactly a 6 on the second die is 1 in 6. Multiply them together, you get 1/36. Same analysis for every one of these possibilities. They're each 1/6 times 1/6, which means the odds of rolling the dice in this exact sequence are all 1/36. And now, since we're saying I can have this or that or that or that or that or that, we're going to add these 6 fractions together and we get 6/36, which becomes 1/6. Okay?
Sounds good.
Number 10. Another one where I see lost points. You pick 3 cards from a standard deck of 52 cards. Find the probability of choosing 3 hearts without replacing the cards as you choose them. So remember, there's 13 hearts in the deck out of 52. So we got 13 divided by 52. Now, since we're not going to replace them, you've done it exactly correctly. It's 12 times 51 times 11 divided by 50. Why did we lose points on this? That's where you stopped writing? No, you put your answer down. Is that not the correct answer? And let me do it real quick on my calculator. 13 times 12 times 11 divided by 52 divided by 51 divided by 50. I get 0.00129. Okay, so it's unfortunate when you lose points on problems like this, Sam, because you understood this perfectly.
I put down that answer that you got.
What she marked off is your pencil over here on the left. This answer that I got is what she put down in ink. Correct?
Yeah.
Okay. But your answer was 0.002 something. And that's strictly a calculator error. In other words, you got to make sure you put this into your calculator. Here, the way I did it, just to make it so you can't make a mistake, is I did 13 times 12 times 11 divided by 52 divided by 51 divided by 50. That's how I did it in my calculator. Instead of what it looks like maybe you did is multiply the 3 numerators, wrote out a number, multiplied the 3 denominators, wrote out a number, and then put this ratio into your calculator. And that involves a lot of potential mistakes one can make. Okay? So if you can solve these kind of problems with one continuous entry in your calculator, you're less likely to make a mistake. You don't want to have to multiply those 3 numbers and come up with an X, and multiply these three numbers, come up with a y, and then solve what one number divided by the other is. That's just ripe for opportunities to make a mistake.
Yeah.
All right. Okay, should I just go down here to where we've got, let's see, number 2. Horizontal asymptote. Oh, that's not minus a point. That's your horizontal asymptote. So you got number 2 right. Okay. I guess that's why she uses ink, huh? So that we can tell the difference between your stuff and her stuff. All right. Let's talk about this graph. This is definitely one of your 10 elementary functions, and you need to be able to know what the parent graph looks like. So if I were to say y equals, what's the parent function that I want to know how to graph? Number 3.
I forget. Is it like
e to the x. In other words, your parent function's got to have an x on it. That's the independent variable. So e is not a variable. E is a number. E is like pi. Okay, it's not a variable. It never changes. It's 2.71 and change. So the only variable in this thing is the x. So that's always got to be part of your parent function. And that is one of the elementary functions that they ask you to learn. Y equals e to the x. Well, it looks just like every other exponential function, like that. In other words, it looks very similar to y equals 2 to the x or y equals 10 to the x. They're all exponential functions, and they all go through this point, 0, 1. Notice why. Is that when I make x 0, y equals 1, regardless of whether that's e or 2 or 10. Any number to the 0th power is 1. So all of these exponential functions look exactly the same when you first look at them, and they all go through this same point, the y-intercept. So the only thing we have to figure out is how this f of x function differs from our parent function. What two things are happening? Let's do them one at a time. What's the leading negative sign mean?
That it's going to be like a negative function.
What does that mean graphically? What are the consequences? What we're talking about now is transformations and reflections. So negative signs in front of the function mean a reflection over the x-axis. You with me? So in green, I'm going to take that parent function and graph it as a reflection over the x-axis, meaning this point would go down to 0, minus 1. Okay, so the green would be strictly y equal negative e to the x. Now we're going to go from there. And incidentally, when you're doing these transformations, always do your reflections first, and it matters. It matters whether I do it first or second here.
We're allowed to use calculators, so I think I just put it in my calculator wrong.
Well, what you've got down there looks more like a horizontal line. So yeah, you probably put it in your calculator y equal minus 1, although that looks like y equal minus 3. But you still have to know transformations. Am I wrong? I mean, whether you can use your calculator or not, they're going to ask you about transformations at some point in this section. This is not a calculator problem, despite the fact you're allowed to use calculators. This is a knowing the parent function and knowing how its transformation is. Well, the only two things, the only thing, well, let me finish it. The only thing going on after the reflection is moving the whole thing down by -1. That -1 is a vertical shift. So in blue, I'm going to move the whole thing down -1, which means now I go through that point, which is now 0, -2, and there's my answer. Now, you don't necessarily have to draw I did it one step at a time just to make it more understandable. But that's the answer. Okay, and that's what your calculator would give you also. Although I still believe that this was not meant to be done on your calculator. If you don't know these transformations, we need to go back and cover them, because that's a real big part of algebra, is knowing, understanding transformations of parent functions. All right. In order to answer number 4, and I tell every single student this, always start with your general equation. Then it's just a question of plugging it in. Now, it looks like you did everything correctly here, but I don't see any equation, and again, you must have made a mistake in coming up with the answer. But
I forgot to put it over 4, which is 12, because.
Right. That's why the general equation is so important. You have 2 general equations that are going to, you actually have 3. You have to know the difference between all 3. Okay? Here's the first one. A equals the initial times 1 plus r to the t. That's for annual compounding. Okay? If you have greater than annual compounding, then the general format is different. It's A equals your starting amount, 1 plus r over n to the nt. So here's the equation that applies to this model. Because they're compounding your interest monthly, what is n going to be? Well, in this equation, what does n mean?
It'll be 12.
It's the number of times per year you're compounding. So it would be 12, you're correct. So the A is going to be your starting amount times 1 plus, the interest rate is 0.06, but I got to divide it by 12, and I got to multiply it by 12 times 10. So the exponent becomes that. So that is what you want to put into your calculator to come up with the answer. Okay? Now, that is something that is a lot harder to do on, I can't even do it on my calculator because I can't do exponents, but you can do it on yours. And
what would T be?
T would still be 10. It's 10 years, but there's the general equation. You got to use the general equation. And the general equation calls for multiplying T by N. Well, N was 12, T is 10, that's 120.
Right.
Now, do you have to come up with an answer here? I mean, do you have to resubmit these and come up with the proper answer?
Yeah.
Okay. Let's make sure you know how to get that properly in your calculator. What kind of calculator are you using? Okay, that makes it a little tougher. If you had an Inspire, the Inspire is perfect at showing you exactly what you're putting in. The TI-84, there's 9 ways to Sunday to make a mistake on this thing in the TI-84. Okay, so here, let me recommend the best way I think there is to do it so you don't make a mistake.
Okay.
First of all, find out what this is. Do you have your calculator in front of you?
Yeah.
Give me a number for 1 plus 0.06 divided by 12.
Okay.
It's 1.00 something.
1.05.
Okay. So that's what you're taking to the 120th power. Now do that. Come up with a number.
Yeah, I got that.
What is that number?
It's
1
1819.
point? What is the number? What is this number to the 120th power? It's not going to be overly big if you're expecting a giant number. It's not.
It's like 1.8.
1.8 what?
2.
Okay. Now we're going to take this number and multiply it by that 1,000. So every digit is significant. What's the next digit after the 2?
It's 3.
Okay. All right. Because when we multiply this by 1,000, here's what we get. Those dollars. That's why those digits are important. And I don't know what your teacher expects. Does she expect dollar answers to include cents, or are you supposed to round it to the nearest dollar?
It didn't specify, so I just put it like
Well, here's the safest thing. If she didn't specify, I would make sure I had the cents in there, which means you need 2 more digits. In other words, you got to be careful about rounding off to the hundredths place, especially a number that you're going to end up multiplying by 1,000, because these 2 digits are actually going to be significant. That's your cents. We got dollars and cents. I don't know whether she requires the cents or not, but if she does, you got to go back and retrieve those 2 digits. Go ahead and take that number to the 120th power again.
It's 1/8.
Hold it. When you say 1/8, it's 1.8, right?
Yeah.
Are you sure your calculator is giving you as 1.8?
Yeah.
Okay, go ahead. 1.8.
1.819. 39.
One more.
6.
The reason I needed the one more is because I needed to know whether I was going to round that up or down. In other words, that 9 is a key digit. Well, I got to round it up because it's followed by a 6. So this whole thing becomes 40 if I'm rounding. Now, when I multiply that by 1,000, I get 1,819.49 cents. There's my answer. That's what your $1,000 is going to turn into at the end of 10 years at 6% per year, compounded monthly.
Okay.
But I'll bet she wants all 6 of these digits. I bet she wants dollars and cents. And so the safest thing you can do on your end is to carry that thing out for as many digits as you can almost. Carry it out. What's critical is knowing that I'm going to take this number and multiply it by 1,000. Okay, and what that tells me is I really need 5 digits after the decimal point that last one needs to be rounded up or down properly. All right. The key to these kind of questions is you have got to know your general formulas. There's just no two ways around it. You stand no chance at all if you don't know your general formula. It's impossible to even come close to getting these questions right. If you use the wrong general formula, you can't get it right. You've got to use the correct general formula. In other words, one of these is if you have annual compounding, and the other one is if you have more frequently than annual.
Yeah.
And then there's a third one let's talk about. It's called continuous compounding. That's completely different. That's A equals, I refer to it as PERT, but it's really A sub 0 e to the RT. And if the question said the bank was going to continuously compound it, this is what you would want to use. There's no N required. All you need to know is the 6%, that's R. T is in years, piece of cake. So it actually would be a much easier solution if they did say continuous compounding. You don't have all of this stuff here where you have these real tiny numbers taken to these giant exponents, which is always a little strange to do when you're used to doing stuff like squaring stuff and cubing stuff. You don't have a lot of experience in taking things to the 120th power. So few people have a feel for what that number should be.
Yeah.
All right. So you got 5 and 6 and 7 correct. Let's look at 8. Now, you used continuous decay, and you also used a positive R. You need a negative R because this is depreciating.
Yeah.
Okay? So instead of 1.12, it's 0.88. In other words, we're using, and I'm actually not sure if she wanted you to use continuous depreciation either. Most of these classes tend to treat this with annual depreciation using this first formula, not the last one. But the fact is that she marked your answer wrong, but she didn't mark your setup wrong. And she should have even if you were using continuous. But I don't believe, she didn't say use continuous. And it's not clear. Once again, this problem could have been stated a little bit better. But let's look at it and use annual. Because I'm next to positive that that's what she wanted you to use.
I'm pretty sure I used annual.
No, I can tell by your formula here. Well, okay, yeah, it does look like you used annual. So you did it exactly correct. The only problem you did was you didn't make R negative. In other words, it's really plus or minus R, and when R is depreciating, it's minus. I mean, that's easy enough to remember. When something's growing, I need a number greater than 1 in the parentheses. But if something is decaying or depreciating, I need a number less than 1 in the parentheses. So it's 1 minus 0.12 to the 8th. That was the correct setup. What she really should have done was drawn a line through your 1.12. And then it would have been enough for you to know you did it wrong. By just drawing a line through the answer doesn't help you much because that could have been a calculator error. But there's your answer. So again, the way I would do this is take the number 0.88, raise it to the 8th power, whatever you get, multiply it by 75,000. The problem with starting with the 75,000 as the first thing you put in your calculator is it's too easy to make a mistake and include that in what is going to be raised to the 8th power. And it is not. That 8 exponent does not apply to the 75,000. So to avoid making that mistake, I recommend everybody do this part first, take your answer, multiply it by 75,000, you got your answer. Do you get a reasonable number?
Yeah.
What do you get?
It's 26,972.6.
Again, I would want to know what that other digit is. Well, maybe not. She may not care about the cents. So I might be way off bounds there. But if she does not care about the cents, then the answer is $73, not $72. Understand?
Yeah.
Why? I mean, if we're going to round it to dollars, let's round it properly. If we're going to include cents, then let's have both of them, and let's round this one properly, meaning we actually need that third digit after the 6. So to be safe, you should always make sure you have dollars and cents, then she can't mark it wrong no matter what. And that looks like what you did in this answer. That's a decimal point there, is it not? Wasn't your answer $5,697.24?
Yeah.
Okay. So you were putting the cents in. So if you're going to put in cents, make sure that you take this number, when you take it to the 8th power, that you have at least 3 numbers after the decimal point.
Yeah.
Okay, that's the secret. And it's not the 1.12, it's the 0.88. All right, let's go on. Let's be done with those kind of questions and get into more traditional algebra. All right. What is b to the 4th divided by b to the 3rd equal to?
B.
Correct. In other words, what do you do with the exponents?
You get rid of them?
You subtract them. You don't get rid of them. There's no getting rid of it. If this would have been b to the 5th divided by b to the 3rd, that's b to the 2nd. There's rules of exponents. Okay, let's go over them. B to the a multiplied by b, let me use x and y. B to the x multiplied by b to the y is the same base, but you add the exponent. B to the x divided by b to the y equals b to the x minus y. And finally, b to the x, all taken to the y power, you're going to multiply exponents. Those are the 3 rules that govern all of these problems. So every problem we're about to look at, you got to know these 3 rules. Well, in this case, the b is e. That's a number, but the key part is that it's the same number in the numerator as it is in the denominator. So is all I got to do. Now, the 20 is not affected by that 28, nor is the 12 affected by the 19. Here, I keep forgetting that when I point with my cursor, you can see where I'm pointing. When I point with my pen, you can't. So the very first thing I'm going to do is handle the numbers independent of anything else. I'm going to divide those two numbers. That's 20 divided by 12. Okay, which is the same as 10 over 6 or 5 over 3. So I do the numbers first. Now I'm looking at multiplying that by e to the 28th over e to the 19th. What are you going to do with that?
Cancel that.
You mean just like that?
Well, I cancel that accordingly to like...
According to what? That's what I'm asking. Give me what the answer is. E to the 28th divided by e to the 19th.
Would it be e to the 9th?
There you go. That's not canceling them out. That's subtracting the exponents. And there's your answer. You don't need a number. That's a perfect answer. That's the best answer she could see. In fact, she would much rather see this answer than see the decimal approximation that you'd have to write. And at this level of algebra, all teachers are going to want to see exact answers, not approximations. Okay? All right, let's go to number 10. We got the cube root of 125 e to the 12x. Well, this is a problem that I can do in two steps. First of all, let's write it with a fractional exponent because it's going to be easier to figure out. Okay? So the fractional exponent for this thing is what? What's the equivalent of the cube root? What's that? It's 1/3. I couldn't quite hear what you said. The 1/3 exponent means the cube root.
Yeah.
Okay? Now, we have that applies to everything in the parentheses. So, what's the cube root of 125? You should know when they ask you questions like that, the answer is going to be a small whole number. Well, it's not 2, it's not 3, it's not 4, but it is 5. Okay? Now, applying the rules of exponents that I just showed you, we have that double exponentiation going on. What do I do when I have double exponentiation going on?
You multiply?
Correct. So what's my rest of this?
I don't know that easily. If you multiply 12 by 1/3, it'd be 4x.
That's 4x. The base does not change. The base is e. The exponent is the only thing that changes. There's your answer. Okay?
Okay.
In other words, you always carry the base forward no matter what you're doing. Even in these 3 previous problems where I wrote those formulas, notice that the only way you can apply these rules of exponents is if the base is the same. In other words, if I have 2 to the 3rd times 5 to the 7th, that's not 10 to the 10th. I can't do anything with this. Okay? I've got to have the same bases. And the base carries forth. In other words, these 2 bases become that base. These 2 bases become that base. This base becomes that base. The only thing you operate on is the exponents. Okay? Let's go to number 11. Now, let's talk about timing here. When is this due? When do you have a test coming up, or does this have to be submitted at a certain time?
I have nothing coming up.
You have nothing coming up? You just have to get through all this material?
Yeah, I just need to, not even get through, I just need to turn in corrections.
Okay. I don't think doing longer than hour sessions is beneficial to you. It's awful hard to do hard math for more than an hour. The brain just stops taking in information.
Yeah.
So if you would like, I can schedule another hour for later on this evening. And I also have a lot of time off next week because most of my students are on spring break next week.
Yeah, that might be good because it's not like this is due at any specific. It's just due by the end of the semester.
Okay. Your mom indicated that you might need more than one session.
Yeah, she doesn't really understand how long it takes, so she doesn't know.
Well, no, I know. She was hoping you'd cover all of this in one session today? Yeah, probably not. I knew we weren't going to be able to when I looked. So let me look at next week, and you tell me.
Yeah.
Well, I got more than I thought I had. Got some people that have just made sessions. So this is what my next week's calendar looks like.
Mom, I can't get it done today. You don't have to call and then... No, we can't. I know, I'm doing it right now, Mom. You don't have to, listen to everything. Sorry, Mom. Okay,
Alright, go ahead and pick from that calendar. This probably...
Can we do Tuesday at 8 o'clock? Or 7? No, I can't do 7:30 o'clock.
So you have school next week.
Yeah, but I have an off period.
Okay.
At 7, I don't know. Yeah, I know. Yeah? Okay, sure. Can we do 7:45
On Tuesday?
Tuesday?
Sure.
7:45, in the morning?
Yep. Here, let me write it in here so that I'll... And we'll go to 8:45 and then see how far we get. Okay. All right, Sam. So I will talk to you. All I will do is text you the meeting ID number at 7:45, and then you can call me whenever you get logged in.
Sounds good.
Does that work? Okay.
Okay.
All right. Bye-bye.
Thank you.